So as you saw in the previous video, seamounts are basically barriers in the way of ocean currents. And when ocean currents hit them, they can't go through them. So often they have to go up and over them. And when they go up and over them, they take water that started at depth that has been gathering marine snow and other nutrients in it, for perhaps thousands of years. It takes that really nutrient rich water and wells it up to the surface. And when it wells it up to the surface, it comes in contact with sunlit areas, right? Areas in the photic zone where plankton live. And it causes there to be this lush, nutrient rich, sunlight filled habitat that are very fertile. And this is where communities of marine life like sponges, crabs, sea anemones, commercially important fish, and deep sea corals can all live, right? So even though um, they don't produce any sort of like hydrothermal fluids that have a lot of minerals within them, such as a hydrothermal vent, because that water is upwelling over them, they still have a lot of nutrients that life needs. And researchers have been investigating the interaction between seamounts and ocean currents and the role that they might play in what we call biological hotspots, which are these critical locations for new species formation and biodiversity. And what we have found is that on these seamounts, they hold really unique ecosystems that often aren't found anywhere else in the world, right? It looks like the creation of these species started here. For example, deep sea corals that thrive on and around seamounts host over 1,300 different species of animals, some of them being unique to the seamount themselves and not living anywhere else. Right? So scientists are investigating whether seamounts act as like stepping stones. Essentially, if life like this can, evolve on a seamount and create this really lush ecosystem, can those communities um, hop from seamount to seamount? Can they spread? Or do they allow other species to hop, right? So, for example, if a coral forms and it hosts a community that has, algae and small fish and things like that, maybe that's like a stepping stone for larger fish, such as tuna, that migrate great distances. And they can basically stop at these buffets along the way of their much, much longer journey, right? So these hotspots can act as these stepping stones that are necessary to be there in order for these more wide swimming organisms, such as tuna, to be able to continue living on their long journeys. Right? And seamount isolation may make their communities a lot more sensitive to human disturbances, such as fishing and mining, right? So, for example, when we mine for corals or when we trawl for fish, we use nets that rake up everything beneath them, right? Just because we want one type of coral or one type of fish doesn't mean that we can target that organism. Instead, we have to rake up everything um, and then take out what we want, essentially kill everything we don't. So in the image here, you can see that A and B would be a seamount post trawling. And then C and D are what's left after that trawl has come through. And you can see that the trawl has raked up all of that life. Um, so if these like scars exist in the ecosystems and we take out one of these stepping stones, that might make the distance between existing stepping stones too great or too far for the connectivity of these wider ranging organisms to still be viable. Okay? So recall currents often do what along seamounts?